What's up, guys? And I'm so happy to see that my audio is actually working today. I'm learning all these little things that I got to check when I go live. Randomly, when I was doing the interview with Zach Daniel, something with OBS was screwing up my microphone input. And when we finished the interview, I just restarted OBS and everything was working. So that's annoying. But today is going to be an exciting day. We are going over the IO and file system section from the Elixir Getting Started guide. So I'm going to go ahead and open up my browser. And let me switch screens. There we go. Make that bigger. That's probably good. And then we'll go to elixir-lang.org and hit up the guides. And we're going to go to IO and the file system. All right, cool. So this chapter introduces the input-output mechanisms, file system related tasks, and related modules such as IO, file, and path. The IO system provides a great opportunity to shed some light on some philosophies and curiosities of Elixir and the Erlang VM. Looks, yep, chat is working. Like it's just a good day. Yeah, for real, Mike. You just got to turn it on and turn it off. I don't. I have to try to turn OBS on and off during a live stream though. I'm worried that I don't know if I can enter the same stream again. I might be able to as long as I don't end the broadcast. Maybe we'll have to experiment someday. But is IT Crowd Style a show? I don't even think I know what that is. Is this something I should be watching? I feel like it's something I should be watching. I don't know. We'll find out soon, I guess, when you guys answer me. Dang delay, like the suspense. All right. So the IO module. The IO module is the main mechanism in Elixir for reading and writing to standard input-output. And that's an atom of standard IO. Standard error is STDERR. Files and other IO devices, usage of the module is pretty straightforward. So IT Crowd is a British show. Nice. I'll have to check it out. British comedy is hit or miss with me. Sometimes I love it and sometimes I can't stand it, but maybe I'll love it. I'll try it out. If it's similar to like The Office humor, the original, the British version, I'd probably like it. But if it's like Mr. Bean, I probably won't like it. All right, I need to close my terminal because it's open in another window. All right, terminal. All right, I'll make this bigger for us. Okay, I'm going to CD to the desktop because I think we're going to be creating some files and a whole lot of fun stuff in this section. So the IO module, we've kind of seen parts of it before. So if we start an IEX shell, we can do IO puts and send a message string of hello world. And there we go. It outputs hello world. And we can do things like IO gets. Let's see, IO gets, and we can send a message yes or no question mark. IO, it helps to use the proper function. And we can say yes. It needs to be a string, I believe. Well, let's try it. There we go. Yes, and it returns a string with a new line syntax. So all sorts of cool stuff. And IO gets just waits for an input. So by default, functions in the IO module in the IO module, read from the standard input and write to the standard output. We can change that by passing, for example, a standard error as an argument in order to write to the standard error device. So if we do IO puts standard error hello world, let's see what this does. I'm going to just clear this so we're at the top. So IO puts standard error hello world, and it returns. Did I do something wrong? Oh, it just I don't know what it just did. There we go. I don't know what happened here. That's weird. So by default, functions in the IO module read from the standard input and write to the standard output, and you can change that. So we wrote to the standard error hello world as the first argument instead of the standard input, which was standard IO. All right, good to know. The file module. The file module contains functions that allow us to open files as IO devices. By default, files are opened in binary mode, which requires developers to use a specific bin read arity2 and bin write arity2 functions from the IO module. So let's see. We're going to have to pull up our terminal. And if we're going to open a file, we obviously have to create a file. So let's go ahead and just do touch, and we'll call this hello, and that'll create a file on our desktop called hello. And then if we do, we can, so file.open returns a tuple. So we're going to get an OK atom and then the file, which is actually going to be a process ID, a PID. So if we do file.open, and then we need the path to our file, and I'm just going to drag that there, and we get the path just like that. And then close off that double quote, and we're going to say we want to write to this, and then close off those parentheses and hit enter, parse error. What did I do? File.open. File.open, parse error. I did something wrong. Does it not like? It doesn't like something. Maybe it doesn't. ZHS parse error. Oh, I'm not in the shell, guys. You guys are probably yelling at me right now in the chat. Ah, yeah, thanks, Sasha. I'm a little slow. I get confused because, you know, I was creating a file and then I forget what I'm doing. And, you know, life is hard. Today's been a busy day. What's really cool, though, is I started playing around with Ash, the Ash framework, which is really dope. I'm just repeating what I already did. And I already have, I almost have most of my blog set up for Elixir Mentor website. So that's pretty sweet. There we go. Now it works. Look at that. We got our PID back. So that is cool. And now if we want to write to this file, we can do an io.bin write. And we just pass in our PID ID, which is stored in our file variable, and then what we want to write to the file, which is world. And we should get an OK atom back. And now if we open up, I'm going to quit the shell. So remind me to open it back up. If I do vim hello, look at that, world is in there. So that's cool. And then we can quit this back into the IEX shell. And we can also do file.read and pass in our path. And there we go. And we get an OK atom. and then the context of our file. So that's fun. A file can also be opened with UTF-8 encoding, which tells the file module to interpret the bytes read from the file as UTF-8 encoded bytes. Besides functions for opening, reading, and writing files, the file module has many functions to work with the file system. Those functions are named after the Unix equivalents. For example, file.rm, arity1, can be used to remove files. File.mkdir, so make directory arity1, will create directories. And then file.makedirectory _p arity1 to create directories and all their parent chain. So there are even file.cp _r and file.rmrf to respectively copy and remove files and directories recursively. So copying and removing the context of a directory as well. All right. So if you were just to delete a directory, if files were in it, you'd get yelled at. But if you recursively remove everything inside the directory, you'll be able to delete that. You will also notice that functions in the file module have two variants, one regular variant and another variant with a trailing bang, the exclamation point. So for example, when we read hello file in the example above, we used file.read arity1. Alternatively, you can use file.read. Trailing bang arity1. And what that will do is if the file doesn't exist, it will just throw an error back instead of returning an error in your tuple like this. So if you want to control your error, you would do .read without the explanation point. And if you just wanted to throw an error, you use the explanation point. And you'll see this a lot in your CRUD actions. So in your context file, when you're fetching data from your database, you'll see the same syntax there as well. So let's try this out. And let's see. All right, so we already know we can read a file where we know it is, and we get OK world. But now if we go ahead and throw the exclamation point, I don't know why I always struggle with that word, but I do. Now we just get the context back and not the atom with the OK. All right, and then if we try to read an unknown directory, we get a file error thrown right with the exclamation point. And then let's go ahead and remove that, and we'll get our error atom back. So there we go. It's a little cleaner to do it this way, in my opinion, because then you can handle the error however you want instead of it just throwing a file.error at us. You don't want broken code. So notice that the versions with the exclamation returns the context of the file instead of a tuple. And if anything goes wrong with the function, it raises an error. The version without the exclamation is preferred when you want to handle different outcomes using pattern matching. Yeah, so in a case statement, there you go. You can pattern match to what is returned. So that's cool. And let's go ahead and do this because I feel like we got to do all the examples. So we're going to say case file.read, throw our path in there, and then do, and then inside here we're going to get an OK back, and then the body of our file, and we can do whatever we want here. So we could do IO puts. I might have to say inspect body. And then we can go ahead and have our error here. And the reason, we got to close that tuple off. The only problem with doing everything in the IEX shell is if you have a typo and you're on a multi-line thing, you got to redo everything. IO puts, inspect, reason. All right, let's hope this works. And there we go. We get world back. So kind of cool. You can handle, And another thing that's annoying in the shell is I can't just use the up arrow and get this back, not easily at least. We have to do this. And I think that's annoying. And now I don't even think, I can't go to previous lines. So like if I want this to be a wrong directory, I have to do that. Okay. And there we go. We get our error back. So pretty cool. All right, where were we? However, if you expect the file to be there, the bang variation is more useful as it raises a meaningful error message. Avoid writing that. So yeah, if you're not handling an error, you don't want to just assume you're always getting your OK tuple back. So as in case of an error, okay, as in case of an error, file.readArity1 will return an error and a reason, and the pattern matching will fail. You will still get the desired result, a raised error, but the message will be about a pattern which doesn't match, thus being a cryptic in respect to what the other error is actually about. So that's also good to know. You want to handle your errors so they make sense. So if we go ahead and do... I'm going to rewrite this. So if we were pattern matching to an OK atom and get in the body here, and then we read this path that isn't going to match to our OK atom, you get a match error instead of the file, like what, let's see, I forgot what it said. And instead of getting, our error message here. So it's good to know. You want to handle your errors. Okay. Therefore, if you don't want to handle the error outcomes, prefer to use the functions ending with the exclamation mark as file.read exclamation arity1. All right, cool. Zach's streaming right now too. Y'all should coordinate. He uses Algora. So I tried to use Algora the other day, and I accidentally took a scheduled live stream live with it because YouTube was using stream keys, all like the same stream key for multiple streams, and things got weird. And then I realized I don't know how to make the comments show up from the multiple streams. So I have to figure some of that out. And then I might use Algora as well. It does seem nice. I just haven't had time to putz around with it more since I accidentally took a scheduled stream. Zach's stream actually live. I think some of you jumped on and saw that happen. So that kind of sucked. That was a bummer. So you can do all your Unix style file and folder manipulations in Elixir like you can with Bash script. Yes. Yeah. You can open files and go through and create directories, all that good stuff in Elixir. Yeah, I don't see any point in using bang. Like, I mean, if you want it just to fail, like if you assume the file's there and you just want it to fail and you still can get a error message that you understand, I guess you can, but I personally think it's better to handle all your errors accordingly. I think it just makes for better code and it's better for reading. Yeah, I agree completely, Mike. Pattern match to a variable makes a lot more sense. So on to the path module. But yeah, we should coordinate. Yeah, but at the same time, like coordinating, like I don't know when everyone's going live. Sometimes I don't even know when I'm going live. You guys just have to choose me over other people. That's what you have to do, Choose your favorite character. Unless it's not me, then still choose me. All right, the path module. The majority of the functions in the file module expect paths as arguments. Most commonly, those paths will be regular binaries. The path module provides facilities for working with such paths. All right, so we can build paths here. And if we pull this up, we can I'm going to clear this so I'm at the top. So if we do path.join And we can pass in two strings here. Foo bar. And when we hit enter, it joins them with a /. So you can build paths with path.join. And then you can also use path.expand. And we can do the tilde and then / hello. Whoop. And then close those quotations and parentheses. And when we hit enter, it will show the full directory from where I am, which is nice because using path expand is usually, oriented to the project directory, when it's all compiled, and you don't always know the full directory, or that's where you make a bug because you assume the full path and you get it wrong. I have done that in my noob days, and it happens to the best of us. Using functions from the path module as opposed to directly manipulating strings is preferred, since the path module takes care of different operating systems transparently. Finally, keep in mind that Elixir will automatically convert slashes into backslashes on Windows when performing the file operations. Okay, that's good to know too. So if you're writing in Windows and then deploying on Linux, you could run into an issue there, right? So with this, we have covered the main modules that Elixir provides for dealing with I/O and interacting with the file system. In the next section, we'll peek a bit under the covers and learn how the I/O system is implemented in the VM. Oh, back to processes. This is fun. Let's see, do we have anyone talking? No. All right. So you may have noticed that the file.open arity2 returns a tuple, and it returned an OK atom and then our PID. And we can do that again. We can open up our hello. So file. I forgot. I think I'm on the desktop. So file. Oh wait, we want to store this in a variable. Okay. File, and then we want to do file.open. If I do hello here, I think I'm already on my desktop, but if we're not, we'll get in there. We'll find out very soon. So there we go. And as you can see, we get our PID back. And this happens because the I/O module actually works with processes. See previous chapter. We already know our shit, guys. We did that last week. Given a file is a process. When you write to a file that has been closed, you are actually sending a message to a process which has been terminated. All right, so if we close our file, if we say file.close and pass in our file, that is now closed, and we can't do our I/O write anymore. So file, is anybody out there? Error. So Erlang error terminated. The device has terminated. So it never found our process. So let's see more detail of what happens when you request I/O write with a PID and the binary. The I/O module sends a message to the process identified by the PID with the desired operation. A small ad hoc process can help us see this. All right, this is fun. So if we we're going to store our PID in a variable, and we're going to spawn a process, and our function is going to, let's see, we're going to listen for a message with receive, do, and then message, and then we're just going to IO inspect the message, and okay. Undefined function. Guys, I gotta learn how to spell. Let's do this again. PID, receive, and all right, there we go. So we have this process that is listening, and then we can go ahead and write a message. So IO write, and we're going to send a message to our spawned process that we just created called hello. All right, and then when I hit enter, we get an Erlang error terminated. So IO request. So let's see. After IO write, we can see the request sent by the IO module printed out 4 elements tuple. Soon after that, we see it fails since the IO module expected some kind of result, which we did not supply. All right, so by modeling the IO devices with processes, the Erlang VM allows us to even read and write to files across nodes. Neat. All right. So IO write was expecting a return message and it didn't get that. So that's why it was terminated. So IO data and char data. In all the examples above, we used binaries when writing to files. However, most of the IO functions in Elixir also accept either IO data and char data. One of the main reasons for using IO data and char data is for performance. For example, imagine you need to greet someone in your application. So you have name and then you set it to a string and then you can just concatenate it together and there you go. And then it will return hello Mary, right? So let's go ahead and try this. Let's clear this. And I already forgot the example. Name equals Mary. And then we can say IO puts hello space double quotation, concatenation operator, name concatenation operator, and then another string, exclamation, and close that off. And there we go. We get our hello Mary. So in the example above, there is no copying. Instead, we create a list that contains the original name. We call such lists either IO data or char data. Oh, I skipped a line. I knew that didn't make sense. Given strings in Elixir are immutable, as most data structures, the example above will copy the string Mary into the new Hello Mary string. While this is unlikely to matter for the short string above, copying can be quite expensive for large strings. For this reason, the IO functions in Elixir allow you to pass instead a list of strings. So we can now do the same example we did above. We have Mary in our variable still. So if we do IO puts and we now have a list with hello, name, and then exclamation, and then we can hit enter, we still get our hello Mary back. And then in the example above, there is no copying. Instead, we create a list that contains the original name. We call such lists either IO data or char data, and we will learn the precise difference between them soon. Those lists are very useful because it can actually simplify the processing of strings in several scenarios. For example, imagine you have a list of values such as apple, banana, lemon that you want to write to disk separated by commas. How can you achieve this? One option is to use enum.join and convert the values to a string. Yep. All right, so let's go ahead and do this. So we already did this in the enum module. We learned about these functions. So we can take a list of strings like apple, banana, and lemon, and then close off that list. And then we can say we want them joined by a comma, right? And then close that off, finish off our function parentheses there. And there we go. And we have the new line there because I accidentally hit return. But anyways, you get the point. So the above returns a new string, copying each value into a new string. However, with the knowledge in this section, we know that we can pass a list of strings to the IO/file functions. So instead we can do enum intersperse. Okay, and let's see, let's try that. So if we do enum intersperse, and we're going to pass in a list, a string apple, and then we're going to pass in another, a string banana and a string lemon, and then intersperse between a comma. And then when we hit enter, what did I do? Oh, I forgot to finish my list. There we go. So now when we hit enter, we see that intersperse. Let's see. So IO and char data do not contain strings, but they may contain arbitrary nested lists of strings too. So intersperse just created a list, and it put our commas in between each value in our linked list. And then so IO data and char data can also contain nested lists. So we can do the same thing here. So we can do IO puts, and now we're going to have a list with apple, and then we're going to have another list, so a nested list here, and we're going to put our comma here, and then have a banana in there as well. And then we can have another nested list with another comma, and then our lemon value. And then we have 3 lists that we have to close off. And there we go. And we still get, so we get apple, banana, and lemon back. Okay. So IO data and char data may also contain integers. For example, we could print our comma separated list by using the question mark comma separator, which is the integer representation of a comma 44. All right, so if we put the question mark in front of a character, it returns I believe it's the ASCII number, right? No, maybe the code point representation. So the difference between IO data and char data is precisely what said integer represents. For IO data, the integers represent bytes. For char data, the integers represent the Unicode code points. Yeah, so this will return the code point. So for ASCII characters, the byte representation is the same as the code point representation, so it fits both classifications. However, the default IO device works with char data, which means we can do, all right, we got a couple examples to try here before we go any further and confuse ourselves. All right. Hey, Yeesh. Sorry if I butchered your name. I tried. Mike, I'm on Windows and I'm using WSL. There's just too much hassle in running it on Windows. I hear you. I'm not a fan of Windows personally. Bcrypt Elixir won't work on Windows unless you get some other deps. Oh yeah, I've seen that. I've seen people get confused by that a lot with my projects, and I don't know what to tell them. I always just reference them to someone that has already solved the problem. You like WSL couldn't. All right, I mean, it works. That's why the Phoenix templates has incredible performance. Lots of bananas today. Lots of bananas. Hey, I've been learning Elixir recently and have watched a few of your videos. Doc tests are the coolest. Doc tests are the coolest. I agree. They are really cool. And you know what? I love that. I hope that means you are watching my testing playlist, and that makes me so happy. That is my least popular playlist, and shame on all of you guys for not wanting to learn how to write tests, because they're important. All right, back to the docs. I forgot what I was doing. Okay, so let's see some code points. So I'm going to clear this so we're back at the top. So if we do IO puts and we pass in a list of apple, and then we are going to do our question mark comma, like that, comma, and then we need our banana again, and then our question mark comma, and then our lemon, And, oh, all right. So there we go. And Elixir still makes the representation with the proper character because it knows what we want. So the difference between, okay, and I'm going to just copy this. I'm getting really lazy with all these commas and bananas and all of that. So there we go. We still get the string representation of the code points. So that's cool to see. Dun, dun, dun. All right, overall, integers in a list may represent either a bunch of bytes or a bunch of characters, in which one to use depends on the encoding of the I/O device. In the file, if the file is opened without encoding, the file is expected to be in raw mode, and the functions in the I/O module, starting with the bin asterisk, must be used. Those functions expect an I/O data as an argument, where integers in the list would represent bytes. On the other hand, the default I/O device, so standard I/O, and files opened with UTF-8 encoding work with the remaining functions in the I/O module. Those functions expect a char data as an argument, where integers represent code points. Although this is a subtle difference, you only need to worry about these details if you intend to pass lists containing integers to those functions. If you pass binaries or a list of binaries, then there is no ambiguity. Ambiguity. I have no idea. You guys can make fun of me for that one. I know the word, I just can't pronounce it right now. If we're talking code points, they're really cool. Use them to gen a list from a range. Yeah, they can be. They can be beneficial. Especially, I think, I could be wrong with this, but I think code points are more relevant if you're dealing with a lot of like Erlang libraries. No, maybe that's char lists. I think that's char lists. All right, where did I leave off? Okay, finally, there is one last construct called char list, which we discussed in earlier chapters. Char lists are a special case of char data where all values are integers representing Unicode code points. They can be created with the ~c sigil. So it's I think you can just call these C sigil or sigil C sigil, I think is the right way to say it. I always just will say ~c because that's what the little wavy thing is called anyways. So yeah, if we go ahead and follow this example, we just do C sigil hello, we get the char list back in the same way. And if we do a list with where we want our code points back for these letters, we can do that, and it will return our char list ABC. All right, so char lists mostly show up when interfacing with Erlang. Yeah, so that's what I meant, char lists, not code points. As some Erlang APIs use char lists as their representation for strings. For this reason, any list containing printable ASCII code points will be printed as a char list. So like that example we just ran. Whew, all right, I feel like I just talked a lot. All right, we packed a lot into this small section, so let's break it down. I/O data and char data are lists of binaries and integers. Those binaries and integers can arbitrarily nested inside lists. There can be arbitrarily nested inside lists. Their goal is to give flexibility and performance when working with I/O devices and files. The choice between I/O data and char data depends on the encoding of the I/O device. If the file is opened without encoding, the file expects I/O data, and the functions in the I/O module, starting with the bin asterisk, must be used. The default I/O device, which is the standard I/O, and files opened with UTF-8 encoding, expect char data and work with the remaining functions in the I/O module. Char lists are a special case of char data where it exclusively uses a list of integers, Unicode code points. They can be created with the C sigil, tilde C. Lists of integers are automatically printed with the C sigil if all integers in a list represent printable ASCII code points. This finishes our tour of I/O devices and I/O related functionality. We have learned about 3 Elixir modules, I/O, file, and path, as well as how the VM uses processes for underlying I/O mechanisms and how to use char data and I/O data for I/O operations. All right. Whew, that was a mouthful. Sigil. Sigil. Is it sigil? Is it sigil or sigil? I don't know. Sigil? It's probably sigil, huh? All right, so there we go. The I/O and file systems section was a lot of fun. You learned how to read and write to files. You learned that reading a file is actually a process under the hood, which is pretty cool. And since we learned about processes and message sending in the last video, you know how all that works. And the next section is the alias require an import. So that is cool. We'll learn what all of those mean. So when you see them at the top of modules, we should understand what you get from them in the next video. So that was fun. We learned how to read and write. We also learned that Jacob has a hard time reading, and that's okay. But all right, cool guys. Well, thanks so much for tuning in. This was a good one. It's cool to learn how to read and manipulate files. It's cool to understand when you're reading a file, it's a process under the hood. And so, yeah, guys, boom. Thanks a lot. And I'll see you guys on Thursday for the alias require an import section. Enjoying the video? Show some love with a like and hit subscribe to stay updated. To support me and keep the content free, click join for memberships or pick up a course at elixirmentor.com and get free access to my private community. Let's jump back in.